Good morning. So today's topic is Newton's laws of motion. Okay, so this is stuff that ideally from middle school you probably recall the three laws of motion. We're just going to kind of go over them relatively quickly, and we're going to answer our note-taking worksheet. Now, we're probably going to spend today and probably Monday working on this, so this video might end and there'll be a second part on Monday, but you'll use both parts to fill out the note-taking worksheet. Okay. So obviously, if the video ends and we didn't get through all three laws, don't turn in the worksheet. It's not done. Okay? Cool. Let's get right into it. First, we have the three laws. The first law about force and inertia. The second law about force, mass, and acceleration. And the third law about action-reaction pairs. Okay? So, let's get into it. The first law, force and inertia. Our main question and idea for the day is, how does the first law apply to objects at rest and in motion? Okay, so that's kind of the goal. What we're going to cover here today, how does it apply to these two groups? Cool. Here we go. Force. Force is an action that can change motion. You should know that from earlier in the week. A force is what we call a push or a pull, or any action that has the ability to change an object's motion. Okay? Forces can be used to increase the speed of an object, decrease the speed of an object, or change the direction in which an object is moving. Okay, all this comes into play with the first law of motion. Remember, if this goes too fast to fill in blanks, you can always pause the video and go back. Right? So forces often result in some sort of change in motion. Often, not always, but often. Inertia. If you watch Bill Nye the Science Guy, there's always a point where it says inertia is a property of matter. Well, what does that mean? It's a term used to measure the ability of an object to resist a change in its state of motion. So what is a state of motion? So whatever you're doing right now, as long as it's constant, that is your state of motion. Right now, I'm sitting. I am at rest. This is a constant state of motion. So inertia means that I have a certain amount of resistance to changing this state of at rest, right? It would take a certain amount of force to get me moving. And right now, I'm pretty comfortable right here with my coffee. I'm doing pretty good. So, same thing's true if you're moving down the highway. You're at cruise control, you're on 60 miles an hour. You're going to resist stopping. Okay, so that's what inertia is. An object with a lot of inertia takes a lot of force to start or stop. An object with a small amount of inertia requires a small amount of force to start and stop. Okay? So think about this, though. Which type of objects would have more inertia? A 18-wheeler going down the highway at 60 miles an hour? Or a little bicycle going 60 miles an hour down the highway? 18-wheeler or bicycle? First of all, be impressed that a bicycle could go 60 miles an hour. Haven't seen it. But obviously the big truck. Why? More mass. Mass and inertia are connected. Okay. Mass and inertia are connected. The word inertia comes from the Latin word inertus, which can be translated to mean lazy. Okay. So, meaning if you have lots of inertia, you're very lazy. All right. So, classic trick, trying to pull a tablecloth off of a dinner table. You've probably seen it in movies or TV shows. So they pull the table off, and then everything stays where it is. The reason that exists and that happens is inertia. Okay, a classic experiment that you can do at home will be to take a glass or a jar of some sort, place a playing card on top of the jar and a coin on top of the card, and just flick the card off. And ideally, card goes flying, but the coin, like a quarter or something, a big coin, would fall straight down. Because of its inertia, its resistance to fly with the playing card. Okay, so, and it would be more difficult to do with a long table because of that increased distance. There's more stuff on the table and whatnot. So anyways, moving on. Newton's first law of motion. Here is the law. This is it. This is the actual law. An object at rest will remain at rest unless acted upon by an unbalanced force, and an object in motion will continue with constant speed and direction unless acted on by an unbalanced force. Think back to yesterday, or 2 days ago, really. We did free body diagrams. We had in the worksheet yesterday, some of the diagrams had unbalanced forces where there was leftover. It didn't cancel out. So when there is unbalanced force, you are going to change an object's state of motion. But if everything balances out, which means net force is what? If everything balances out, net force is what? If net force is 0, then an object at rest will remain at rest, and an object in motion will remain in motion with constant speed and direction. So this is all only true when net force is 0. If it's not 0, it's unbalanced, and your object at rest is going to start moving. Your object in motion is going to change its motion, okay? So that's what the first law of motion is really getting at. It's all about the net force we talked about. In real life, all moving objects eventually slow down and stop unless you continually apply a force. So think about this. If you kick a ball, it's going to stop eventually. Why does it do that? Is the first law wrong? Isn't it still have that same force acting on it? When something rolls on the ground or flies through the air or falls in the ocean, there is an outside force being applied, an unbalanced force being applied, and that is friction, okay? So it has to do with, like I said, the word net force. So things eventually slow down and stop because the net force is not 0, okay? There's this concept of friction at play that will eventually slow down an object because that is a outside force, an unbalanced force that's acting on an object, okay? So force is acting on a box. In everyday life, all moving objects eventually slow down and stop, and the force we're looking for is friction, okay? Whenever you push something, there is a resistance to motion. The definition of friction, it's a force that resists motion. So if you struggle with the worksheet yesterday, couldn't figure out the direction of friction on your free body diagrams, it's simple. Friction travels in the opposite direction of motion. So if you're going forward, friction is going backwards. If you're going this way, friction is going that way. Okay? Simple. So in order to keep an object with a net force of 0, to keep it moving at a constant velocity, you have to keep applying that force. That's why when you drive a car, if you want to keep it at 60, keep the net force 0, you have to keep the gas going on the car. So friction occurs whenever there is a relative motion between metals, when things move past other things. Relative motion. Friction creates forces that always oppose this motion. And to create motion at constant speed in the real world, a constant force must be applied to make the net force 0. Because there's a constant friction, you need a constant force to balance it out. Friction's going the opposite direction of motion, which means you have to have constant both to have a net force of 0. All right? So that is the basics of the first law of motion. Motion only changes through the action of a net force, and if the net force is 0, there can be no changes in motion. An object at rest remains at rest, an object in motion remains in motion with the same velocity and direction. Okay, so that's where we're going to leave off today, and then we'll pick up with the second and third law on Monday. So notice that this assignment's not going to be due until Monday because you don't have the rest of the notes. Okay, so hold up. I'll see you Monday.